BSc Technologies. My name is Jagan, and we are here presenting two of our products built for the Indian Navy. We are currently building 5 products for the Navy. What we are showcasing here is an RCS measurement device. This measures the radar cross-section of a device. It can be a target, it can be a missile, it can be a boat, it can be a ship, it can be any of the targets. We currently are measuring RCS for Sierra band, X-ray band, KU and KA bands. This is based on a new age SDR platform. So this can be mounted on a drone, it can be mounted on a ship, or it can be also mounted on a terrestrial platform. So this whole device would then be operated remotely when it is mounted on a drone. The RCS that is measured here would serve as a database when you have future targets, when you look at other targets in the future. So this is the RCS measurement device. Then we have the underwater camera. So this underwater camera is something that the diver would be able to carry when they go for a dive operation.
Okay.
So this would be neutrally buoyant once it gets into water, and there are 2 cameras here, telescopic camera and a wide angle camera. Then there is also a sonar, a high resolution sonar. Then there are 2 very powerful lights. The lights are going to be...
These are LED lights?
These are LED and IR lights.
Okay, IR. Even we can see in the
darkness also.
Okay.
Indian waters are so murky. So what happens is you will not be able to see for a longer distance without high resolution cameras and without high intensity lights. So that's the reason we have very powerful white lights. The yellow color lights that you see here, they can actually put out more light than what is coming from this floodlight. So
must be 60 watts or 100 watts?
These are 6,000 lumens.
6,000 lumens, quite good.
Yeah, and they also have IR lights. The camera is also an IR camera, so I can move from the visual to the IR spectrum very easily. And
the wire cable could be as long as we want.
Yeah, so it can currently it's about 125 meters. The whole unit is rated for about 300 meters depth. So because it is rated for 300 meters depth, the whole enclosure is made of aluminium and can also be done with titanium.
So you are the winner of 5 IDEX challenges.
Yeah.
So what are the other innovations?
So we are building an ASA radar, we are building a command system, a communication intelligence system, and we are also building a KU band satellite terminal.
Wonderful. And all on your own?
All on our own.
So how was the government support, and what is the ecosystem now as of now?
So we are very happy to say that Navy has been a partner right from the very beginning in terms of supporting us, right from providing the guidance in terms of the requirements, helping us understand the requirements better, connecting us with the rest of the ecosystem. So today if I need some manufacturing support, I will be able to go and ask my nodal officer who would be the right partner for me to manufacture. When we manufacture something, we get requests from other startups who are struggling to manufacture something.
Suppose for these 2 products which you just showcased, how many partners you need to have in order to develop or in order to produce such systems?
It would be in the order of say 10 to 15 different agencies will be required.
For smaller parts?
Even for smaller parts. So we are very happy that way because we work very closely with Ducom Aerospace, who are our manufacturing
partners. All partners are Indian partners, or you have foreign collaborations as well?
No, we are completely Indian partners.
Very nice. All make in India?
All make in India. So this particular boat is completely built in-house. This is one of our boats that we have made. So everything that you see here, starting from the software to the hardware design to the PCB design, is all done in-house.
Okay. And what this board is for?
This is for the RCS measurement device, and this is also the board that we are using for Doppler radar.
And I could see there are other 2 boards as well. And the chips are also developed in India?
No, unfortunately the chips have to come from outside of India. Currently we don't have the ecosystem to manufacture our own chips.
Yes.
But the rest of it is all completely done in India. The rest of the hardware, the rest of the software, everything is done in India.
Soon we'll also have the chips manufacturing in India.
That's the hope.
Model or it's actual satellite?
This is a prototype. this is actually a scale 1:1 scale model of actual satellite.
Okay, so this would be the actual size.
This would be the actual size.
My God, in this space we'll see such nano satellite, huh?
Yes, yes.
Wonderful.
So it's a 1U CubeSat. It's called a CubeSat because they match the dimensions of 10 centimeters by 10 centimeters by 10 centimeters. So this is a CubeSat standard.
So what kind of studies it can conduct?
So we come up with the basic bus, and then based on the customer requirement, we come up with various payloads. We have already launched 3 satellites, and these have been technology demonstrators to do ground to satellite communication and satellite to satellite inter-satellite communication. So these are typically used for IoT kind of applications. So a small sensor in some remote area can upload data to the satellite, and when the satellite goes over a ground station, it will be able to downlink data. So you don't have the necessity of a constant internet connection. So that's one of the use cases for such satellites. And because these are so small, they can be deployed in a large number. And if one of the larger satellites goes down, it's a very time consuming and a very economic impact that you would have. But once you have a swarm of these satellites, you can cover much larger footprint than one large satellite would be able to cover. So these are for communications, so like device.
And how
to
long
device
they can stay in space?
So these can be up to 4 to 5 years, completely operational. It depends on the altitude in which they are launched.
And thereafter they will lose altitude, will fall in the
Then
space
they will come
atmosphere,
down. Yeah.
and they'll burn out.
Yeah,
Right. So there's no harm.
there is no harm.
Wonderful. Thank you so much.
Thanks.